Hi everyone. In this video I'm going to go through the 3 practice problems we had this week in week 5 on probability and independent events actually. All of these are independent events that we're about to see. So let's get into it. A fair 6-sided die is rolled 3 times. What's the probability that all 3 rolls are 1? Well, these are independent events because the fact that I roll a 6 or a 1 or a 4 the first time doesn't impact the second roll at all. So all I need to think about is what's the probability of rolling a 1 and then just multiply that 3 times because I want all 3 to have that outcome. So the probability that I roll a 1 is a 1 in 6 chance for the first. If this is our first roll. Then we think about our second roll. Well, the second roll isn't impacted at all by the first roll, so it's the same probability again. And then we have our third roll. Our third roll, it isn't impacted at all by the first or second, so 1 in 6 again. So here we have it. These are independent events. I want the probability of a 1, 1, and 1, which is a 1 in 216 chance. So what this tells us is there is one of the 216 combinations in all satisfy this requirement that we're looking for. I'm not going to reduce this down or write it as a decimal because I think this shows more information about it and it's going to be so small that it's not super relevant. It is not likely though because there's 215 other combinations that could occur besides this one. Into the next one, we have a bag of marbles with 3 red, 5 blue, and 7 yellow. 1 marble is drawn, put back in the bag, and a second marble is drawn again. This put back in the bag or return to the bag makes these independent events because nothing's changing. I'm resetting the scenario every time I draw if I were to do it multiple times. What's the probability that at least one of them is red? So this at least one is key to pay attention to because it's going to open up actually multiple outcomes. Look for this question in this week's video. You're going to see it actually if you're working through these sequentially pretty quick here. Because there's an easier way to organize this that we'll get into with a tree diagram. So what I'm interested in is I want red every single time. So I know that 3 of the outcomes are going to be red, but I need to consider all of the outcomes that can happen and think about how many of them have at least one red in them. So straight away, I can have them both be red. So I could have the probability that I draw red, put it back in, and then draw a red again. This would be one of the outcomes, but we can also have other ones. So I could have the probability of red, red, or whenever I say the word or, I'm introducing other outcomes, so I'm adding these. Or I could have the probability that the first one I draw is red and the second one I draw is not red. That's at least one red. These are 2 R's, but this one's red complement, so it's not red. It would be blue or yellow. Or I'm adding another one on. I could have the reverse situation here where I do not draw a red the first time. I put it back in and then I do draw a red the second time. So there's actually 3 ways I could draw at least one red marble. So now I need to think about, well, the probability of drawing a red is 3. I wrote a 2 there. Is 3 of the 15 outcomes. And then if I draw red again, I'm resetting. These are independent events, 3 of the 15 outcomes. So this is the first one. This is both red. Or I can have the first one be red and then the second one be not red. Well, if I have 3 of the 15 red, that means that I have 12 of the 15 that are not red. And we see 5 and 7 make 12. Or I can have this flipped. So I draw a not red first, then I draw a red second. So when we multiply these together, what's nice about these actually is we have a common denominator. This happens a lot in probability. So my denominators are going to be 15 and 15, which is 225 total. Now I need to multiply these. So I have 9 here. I have a 36 outcomes there, and then I have another 36 here. So it looks like 36 and 36 will make 72 plus 9. So 81 of the 225 outcomes have at least one red in it. And we can reduce this down to, I believe, 9 fifteenths. 81, 225, math, enter, 9 25ths, sorry. 15 and 15 is 225. So we would have 9 25ths there when we reduce it down. Or I could say 9 25ths is 0.36. So 0.36 is the probability, or 9 of 25 times. On to the last one. This one is abstract in that we don't really know anything about what this is modeling. We just have probability of A union B is what we want to find. If probability of A is 0.4, probability of B is 0.6, probability of A intersect B is 0.2. Two ways you can do this. Let's run through them both. First one is to use the rule of the addition rule of probability, which says to find the probability of A union B, I take the probability of event A occurring, add it to the probability of event B occurring, and then I subtract the overlap one time because it's counted in A as well as B. So A intersect B is what we subtract. So here, we want to find A union B, so this should be the only thing that's not a number now. So A is 0.4, B is 0.6, and A intersect B is 0.2, which we take one of those out. So now probability of A union B is still there. Let's rewrite it to be consistent. Probability of A or B occurring is equal to 0.4 plus 0.6, which is 1, minus 0.2, so 0.8 we have there. The other way we could do this is we could actually represent it in a Venn diagram if we want to find this. So if we call this event A, and here's event B, we actually know everything to fill out this Venn diagram. This is 0.2. Well, if I have A with 0.2 counted already, I want it to be 0.4. I know this is 0.2 as well, because now we have A in the two regions added together, making 0.4. Similarly with B, I have 0.2 counted, so I need another 0.4 there to get 0.6. And now A union B is this region plus the intersection plus exclusive B. So we'd have 0.2 plus 0.2 plus 0.4, which gets us the same answer here of 0.8. So two ways to do it. This addition rule just removes the visual and it makes it totally abstract. So there we have it, the 3 practice problems worked through. Let me know what additional questions you have. I hope this video helped.